So my talk is going to be about software architecture in a front end. So overall, what my goals are is I want to basically give you guys some concepts of software architecture and how you can start applying this to the front end. So talk's basically broken up in 3 different parts. The first part is we're going to go over just some principles and definitions of software architecture. So we are on the same language when I use some of these, when I use this terminology throughout the talk. Then we'll actually get into applying it. So how do you then actually take all these high-level concepts of software architecture, all these terminology from the 70s and 80s, and how do you actually apply it to your JavaScript front-end frameworks today? And then we're going to break and get some tacos. All right? Sound cool? All right. So who am I? My name is Robert Aguilera. I got 5 years of front-end developer experience. Not to brag or anything, just telling you, I've felt these pains. I've been dealing with this for 5 years. Right now, currently, I am a software developer or JavaScript engineer for Aplos. Before, I was a front engineer for Decipher. Shout out to Decipher crew. Whoop, whoop. Before that, I've also, throughout that time, I just worked in various projects, building stuff with React, Shopify, WordPress, so been all over the front end. And where I used to kind of complain about frameworks and just say, oh no man, it's Ember sucks or Angular sucks, it's all about React or it's all about Vue or any of that kind of stuff, over time I've realized none of these tools are going to solve your problems. You're only going to solve your problems with good patterns and designs. And so as I've been coming across that realization, that's what spurred this talk. So anyways, that's who I am. If you want to get a hold of me, you can go to my website or blog, robaguilera.com, or find me at Robert Aguilera Jr. at Twitter, or Robert_Aguilera_ Jr. at IG. It got late in the whole social media game, so my usernames kind of suck. All right, so let me start off with telling you a story. So there's this front-end developer. And one day she shows up to work and she's got a task. She needs to go through the code base and replace a payment processor. So if you guys have ever worked in an app where you have to initiate some kind of payment, some kind of e-commerce site, you'd be aware that there's these concepts of a payment processor. So an example would be Plaid or PayPal or WePay or any of that kind of stuff. So basically the structure is you have a form, you collect a name, as it appears on the credit card, a credit card number. You guys have probably all, if you ever bought anything off the internet, you know what I'm talking about. So from a code perspective, what ends up happening is you collect all of this data using whatever templating language you're using. Handlebars, JSX, whatever the heck Angular does, right? So you collect all of that stuff and you use some kind of state machine and then you pass it to a function. And in this function, you probably call PayPal, create, process, whatever, credit card. And you drop this payload into it. Now you might have to massage it a little bit, right? Because PayPal is going to expect some specific, gosh, this microphone is really intimidating. So you're going to have to kind of expect some kind of specific format. So you're going to pass that to this create credit card by PayPal function. That's going to return to you another specific data structure. And so you might have to massage that a little bit, and then you're going to pass that into some other, endpoint where you're going to store this information on your back end, or you're going to make another donation or whatever, or you're going to pay something. So her project manager tells her, I need you to go in, we got a better rate through WePay. So I need you to go through and change PayPal to WePay. So what does that mean? That means she's going to have to go through her distributed code base, and everywhere that PayPal is mentioned, she's going to have to change that to whatever WePay needs. But that's not the only change, because in and of itself, that's not that bad. You're going through maybe 10 different files and changing one method call to another. No. What she's got to do, she's also got to change that data structure. So she's going to have to go through all those different places and change that data structure to match whatever now PayPal needs. But then, that's not it, because she's also going to have to go through the spots where it now returns a data structure and change that data structure to match whatever her now new donation endpoint needs. So she's having to go make changes all throughout her code base just to do one thing. So what does that mean? It's very expensive in time, it's very expensive in resources, and she basically complained about it for the next 2 weeks. The end, right? And so that illustrate, hopefully what I'm trying to do with that is I'm trying to illustrate just a couple of the problems that we end up having on the front end. we have a lot of repeated boilerplate code just throughout our systems. Any changes that you make to one thing end up rippling throughout the rest of your system. So you got to change some kind of low-level, specification from WePay to PayPal, or PayPal to Square or Plaid or whatever. You're changing your charting libraries for whatever you're doing on your business end. Any changes to that, you got to change a lot of code. You're not just changing it in one spot. And sometimes in these different spots where you're changing the code, it's similar logic, but it's a little different. So you're calling an API endpoint, that's when you turn to your promise. In some places, you're using a try-catch block because you're using async await. In other places, you're just using the then and catch callbacks. So every place that you have to go to, every place that our hero of the story had to go into, those places that change that code, it was always a brand new introduction. Oh, okay, now I'm in an older app and now we're using promises. So I gotta do this kind of thing. All right, now I'm in something newer. So now I gotta figure out what I'm gonna do here. Now I'm in a React app. Now I'm in an Ember app. Now I'm in something else, right? So it's a lot of work. It's a lot of work from her end. It's a lot of work from the QA team to go through all of these different places and test all this new functionality. It's a waste of time. It's inefficient. And it's boring. I don't know about you guys, but I find that kind of development boring. Maybe some people like it. Cool. Right on. I complain about it. I can kind of get a couple hours in the morning, and the rest of the day I'm just bitching and moaning because it sucks. So that's where I started. My recent task was something similar to that. So that's when I started to look, well, how can I get around this? What else can I do besides, this kind of work? Is there something I can use, a tool, some kind of pattern? And so that's why I started diving into software architecture, because frameworks, they're not the answer. So principles and definitions of software architecture. This is where I'm going to go over some of the words I'm going to be using and referencing throughout the rest of the talk. So first of all, the first thing I learned is software architecture is not about folders and files. It's not about how you lay out the foldering structure of your whatever framework. That's not it. That's a piece of it, a little tiny piece. But really what you're looking for and you're thinking of in terms of the connections between these components. So I got these two functions up here. I got file A and file B. Imagine they're just two different, they're in two different files. File B brings in file A and uses that function do something, and it passes as a payload. How are these components connected? It's a question. What do you guys think? Where are the connections between these two different components, these two different functions? Guys, I'll kill time. I mean, I got time to kill. So just give me just randomly, just tell me where. What do you think? Tom, what do you think?
What's the question again?
DJ.
Payload?
All right, the payload, right? That's one connection. Because file A is expecting payload to be a specific format. So that means file B needs to be aware of that format. It needs to know that it's expecting an object with the properties of foo and bar. That's your connection. Yeah, you're also calling that function, and that's part of the connection. But really, the real connection, or another type of connection, is the data format and what the expectation or the assumption is between file B being able to use file A. I need to call this function and give it a specific payload. So what happens if file A changes? And now it wants a different kind of payload. It no longer wants foo and bar, it wants bar and baz. Now what do you got to do? You got to go everywhere that you've brought in that function and change that payload. Now what if file A gives you back a promise rather than an object? Now you're going to have to go everywhere you brought in file A and change that from just a simple function call to some kind of async await or some kind of promise callback, right? So now any changes to file A ripple throughout the rest of your system. So we tend to think of those changes in terms of volatility. That's another concept in software architecture that we examine when we're looking at our systems. We think of what's the liability of this thing changing and how unpredictable is that? And I like to think of it in terms of a lake. So if the lake is my system, and I'm about to drop a rock that is a part of change, how far are those ripples going to go throughout my system? If I change a function, do I merely just go and change an import statement? Or do I have to go and change payloads? Do maybe if I'm collecting forms, inputs from data, or like data from inputs, do I have to go in and start changing the names on those inputs because now the properties have changed? Am I changing utility functions? Am I changing, is each one of those ripples, is it also like a different system or a different repo? Some of the systems that I've worked in, for example, in Decipher and Aplos, from a user's perspective, it's one app, but from a coder's perspective, it's actually a bunch of different repos that make up the different apps of that repo. So if I have to now change this whole payment processor, am I going to have to go through 10 different repos and make all the changes in there? So volatility is another thing that you try to think of in terms of, if I change one thing, how far is that change going to reach throughout the rest of my system? And that also left me to understand that there's different kinds of logic in the front end. Before, what we used to do, or I used to do, is I used to think of all logic as logic. So I had my React component, and in a lifecycle hook, I hit an API endpoint, and I brought in some data, and then I took that data and I massaged that data, then I shot it to my templating language or whatever component, and it displayed it. And then maybe there were some interactions from the client, and then I sent that back up to the parent component, and then it then did whatever it needed to do there. And so what you're muddling with that is you have this kind of back-end, front-end logic, and then you have this presentation logic, and you're coupling them together. So any changes to any one of those two is going to change the other one. And in software architecture, you're thinking of that as your presentation layer and your specification layer. Your presentation layer is all the stuff that interacts with the UI. Your specification layer is all the stuff that you have to do specifically to get the UI to do its job. So, for example, here's a charting library. So I got these two charts in my UI. My presentation layer is the UI itself. It's just this, I'm showing two charts. Maybe that button, a drop down that, a client can toggle. The instantiation of this component, like using whatever React or Ember or Angular or whatever you're using to build this thing. But the back-end logic is going to be your charting library, right? Does the front end care what charting library you're using? If your product is to show clients some kind of metrics on their data, do they care whether you're using D3 or high charts? They don't care. They just want to see the thing. And so that's where what we're doing on the front end is we're coupling all of this stuff together. And so what software architecture tries to get us to do is think of things in terms of modules. High-level module, low-level module. High-level module is whatever's consumed by the presentation layer. So whatever things you're doing with your JavaScript frameworks to call stuff. Your low-level modules are the things that you're doing to be able to have that high-level module do its thing. So collecting data, processing credit cards, showing charts, so on and so forth. So for me, the biggest change when I started going through all of this was realizing that not all logic is the same. There's different kinds of logic, and maybe we shouldn't group it all together. And you can separate it through the concept of what's called an abstraction. By definition, abstraction is just the act of representing essential features without including the background details or explanations. And I'll dive a little bit more into this and show you concrete examples of abstractions. But for me, on a principle level, I used to think that first example was an abstraction. I have this file, and I have this function, and I initiate this thing called PayPal API, and I have all my promise, I have all of that there, and I just import this file everywhere I need to use it. And I used to think that was an abstraction because I'm cutting down on boilerplate code, right? I don't got to declare this everywhere. Maybe I can even abstract this into a library that I host on GitHub, or I publish it on NPM, and then just import that into all my different repos. But I'm still coupled, because if we ever change from PayPal to something else, what do I got to do? I got to change that, and I also got to change everywhere that I brought it in. I got to change data structures. I got to change my expectations and my assumptions that my functions that I'm in my front end are using on this specific layer, I got to change their assumptions because now maybe they're receiving different things, or they have to give it a different payload. So really, the study of software architecture, if you really dive into it, what you'll realize is it's really the study of patterns. And those patterns are encompassed of what all those concepts we just talked about: modules, abstractions, connections. And what it does is it gives you a system that's easy to reason about, so you can understand what you're looking at. You're not just seeing all of this logic just coupled tightly together and you're just trying to figure out what the heck is going on in there. They can easily shrink and scale, and they're easy to change. And now you would think shrink and scale and easy to change are the same thing, but they're not. Easy to change means I can go and change some existing functionality and it doesn't ripple throughout the rest of my system. I can change a payment processor. I can change a charting library. Easy to shrink and scale means I can add additional features or I can remove features, and it doesn't impact my software system as a whole. Ultimately, to write useful and long-term maintainable software, we want to look for patterns and groups and group them into and put them into abstractions. Because otherwise, what you end up doing is you have these patterns that get repeated. That means that's a lot of code. And if you have to change that code because you got a bug, because your project manager is handing you a new feature, because whatever, you want to remove something, that means everywhere that you have that code repeated, you got to change it now. Any questions so far on software architecture from a high-level concept overview? No, what are they? All right, let's talk about an application. So what we're going to do is we're going to look at specifically a pattern called the dependency inversion principle. And what that is the definition is a strategy of depending upon interfaces or abstractions rather than specific implementation. Okay, it's a lot of words. What does that mean? So let's talk about a real-life example. Here we have an electric socket. In terms of the dip pattern, the socket is our abstraction. The specific implementation is the energy going through the walls. That's the electrical system. And the adapter is, in this case, an iPhone adapter, right? I want power to this phone. Do I got to connect some cord to it and then go to a socket and then start splicing wires together to connect it? No. I connect an adapter and I plug it into the wall. Right? Do I care where the power is coming from, whether it's a generator, whether it's solar power, whether it's just traditional PG&E? I don't care. I don't care about that specific implementation. All I need to do is I need to use that interface, which in this case is the wall socket. I plug into that, I get my power. I don't have to worry about how any of that is implemented within these walls. That is a really good example of the dip pattern in everyday life. You see, because I depend on this socket. I need to know if I need to use that socket, I need to have these two prongs. And then the electrical system knows, okay, in order to deliver power to this, this socket has these wires and I need to connect to those wires. And so it's like a contract. For me to use that socket, the socket is saying, you need to plug in this specific type of adapter. And to the socket is saying to the wiring system, the electrical system, you need to give me these specific wires, and now I can make this connection between the socket and the electrical system, or between the user, which is me, and the electrical system. So that is this definition, this pattern. It's a strategy of depending upon an interface, which in this case is a wall socket or an abstract or an adapter, rather than the specific implementation. I don't have to concern myself with how power is delivered to this building. I just plug my stuff into this adapter and it works. Make sense? Any questions? All right. So if you do get into this and you start reading, because here's what I found. With most of this software architecture stuff, there's a lot of this stuff is from the 70s and 80s. There's some stuff in the 90s and early 2000s, but most of the guys talking about this were the dudes that were building stuff in the early 80s for Sun systems. The guys that were writing Fortran, the guys that were working on the earlier concepts of Java. you know. So a lot of that stuff is pretty, you know, they're talking from a different era. You're not going to, I didn't typically find a whole lot of, oh, here's how you apply, the, you know, the JavaScript div pattern in JavaScript. It was just kind of like, ugh, it's a little hairy. So you're going to come across a lot of these diagrams. And so in this case, here we have an example of the dependency structure of a violation of the div pattern. So we have this main, and this main, actually, give me 1 sec. Yeah, okay, sorry. So we have this main, and this main is a high-level module, right? It is a thing that depends on the presentation layer. My mid can be whatever, but mid's your function that you call to be able to then call some detail. The detail is the specification. So for the example that I gave you of our story, our front-end developer, she's going to come in, she's going to go into the main, which is the presentation layer, and then she's going to have to change the detail, which is the PayPal API endpoint. So what that means is the presentation layer depends directly on that detail. So any changes to that detail are going to ripple all the way up through the main, to the presentation layer, the high-level module. The high-level module depends on the low-level module, so any changes to the low-level module will ripple all the way up through the main. And sorry, there we go. So here's some pseudocode that's going to illustrate this. So down here is my, you know, whatever, my instantiation of my thing. My app, my state management, and here's my process credit card. So here is my dependence on my specific implementation. I have got to massage this data, and I'm going to pass it into this WePay credit card method call. It's going to then return to me a promise. Then I'm going to feed that thing into this payment handler. This payment handler is going to expect these two arguments. It's going to expect that payment info to be in this kind of structure. I am then going to take that, pull some more stuff off that the user card info. I'm going to create a new payload, and I'm going to send that to this additional API endpoint, right? This is our API endpoint that we defined as a system, as an organization. Yeah, I'm going to make a payment to whatever. They're going to pay their subscription costs. So you can see that there's some changes. This is where the violation comes in. I am depending on this. So any changes to this means there's going to be changes here, and means there's going to be changes here. So anywhere that I've implemented this pattern, I'm going to have to go through and change it. And that's the painful part. That's what makes front-end development painful at times. Because now I got to go through and do this all over the place. And then sometimes, yeah, I was pointing out, sometimes this logic's a little different. Like this is what it looks like in a React file, but what if I'm working in a legacy application that we have? I got to now understand what the heck is going on in there. And that can be a little painful. Does anyone have any questions about the violation of the div pattern? So you can see that this was the React component. This was the function that basically called the WePay, and then this is the whole WePay detail implementation part. There's another file somewhere that does all the specific stuff for the WePay, but any changes to this, you can see how they ripple all the way back up. Make sense? All right, so here's the actual div pattern. Here's where we flip it. This is the inversion. Because now our high-level policy doesn't depend on a low-level policy. It depends on an abstraction. That abstraction just sits right in the middle. And so that's going in a sense, kind of like a contract. And so your implementation relies on the abstract, and your front-end high-level module just implements that abstract. One sec. So here's the difference. And there's not a lot of code. Surprisingly, this principle is pretty easy to implement. So the change is I no longer have to worry about the massaging of the data. I just call this payment processor. There's a function called process credit card. and I give it my card info. So the front end there's not a whole lot of change there, right? So instead of this being WePay or a PayPal or any of that stuff, I am just calling this payment processor. And imagine that at the top of the file is this like import statement, import interface from wherever I got this library stored. So here's my interface. My interface is going to, at least in terms of JavaScript, if you try to do this pattern in in .NET or Java, it looks completely different. So this is just from a pure JavaScript perspective. I'm going to import my low-level module. And using alias, I think it's called alias imports, I'm going to call it processor. And the reason that I personally like to do that, if I need to change this, so instead of WePay service, now I'm using PayPal service, I just change here, because I'm importing from a different file, and I don't have to touch the rest of this interface file because I already aliased it as processor. I'm not saying WePay service create credit card, I'm just saying processor create credit card. So here's my adapter. So think of this as the block, the iPhone adapter block, right? The wall wart, I think that's what it's called, cable. This is the thing that's going to massage my data. And then here is the interface. So you can think of this almost as a contract between two different modules that are trying to speak to each other. You got the high-level module, so you can imagine that the interface is saying something along the lines of, hey, high-level module, presentation layer, you can assume that I'm going to return you a promise and a specific data format that you could use. In exchange, you'll need to give me data in a specific format that I can run through an adapter. I'm going to take all of this stuff, I'm going to give, here's a promise, here's massage data, and it says, hey, low-level module. So this is your specific implementation. This is your charting library. This is your third-party libraries that you're using. I expect you to have a function called process credit card. I expect you to give me back a promise with a specific data format. And I will give you massaged data from the high-level module that you could use in order to do your job. And in here is all your low-level, like, specific implementation. Here's where you're doing all the stuff that you have to do to get your charting library to work. Here's where you're doing all the stuff that you need to do in order to get your payment processor or APIs or whatever thing you're trying to encapsulate, whatever thing that's volatile that you're trying to encapsulate away. Here's where all that logic sits. So now imagine, back to the story of our front-end developer as she needed to change all of that stuff, from WePay or PayPal and vice versa. All she needs to do now is she needs to go here. She does all her changes here, and then that's it. Her changes don't ripple throughout the rest of the system because she knows that in here, to be able to create a service, she looks at this contract and says, okay, this thing is going to give me a specific data format. So it's going to give me credit underscore card. It's going to give me an object, and under the object, there's going to be credit underscore card. WePay wants CCN number. So I'm going to do some data massaging, and I'm going to pass it here, and then over here, I'm going to implement all of my specific API endpoints, all of my specific logic, all my if-else statements, ternary operators, all that stuff lives here. It doesn't ripple throughout the rest of your system. And then also, the really nice benefit of this is, for me, it actually makes it easier to develop. Because now when I'm looking at this, I know what I need to do. Because part of the thing is not necessarily how, but also what when I'm building something. When I'm building a new feature, like what is it that I got to do, and then how do I do it? So this gives me a really good blueprint. I need to give this thing a process credit card. How I implement that and do that doesn't matter. Does that make sense? Right? And so that's the really beauty of it. So any changes here, change here, nothing changes here. And here's the thing, like I haven't gotten this far, so don't just judge me, okay? But you can write tests, right? This is where you can actually write all your testing stuff. I imagine. I haven't gotten that far yet. Because, it's tough. You got your, project managers, and they're always, everything is 2 weeks. A bug, 2 weeks. You're building a whole new app, 2 weeks. Everything's 2 weeks to them. So this is where you can actually write all your tests. So even if you were to change your WePay credit, or your payment processors, your charting libraries, you got your tests. As long as your test passed, you probably don't even have to check the UI. You might want to smoke test a couple spots to make sure it still works, but then that's it. You don't have to go through and check every place you use a chart, every place you make a credit card, every place you make a payment. You just run your test here and then that's it. You don't have to duplicate tests per repo, per framework, per anything. It's just all here. This is all your logic right there. And that's the inversion. Now, one thing I actually forgot to point out is there is a little bit of coupling. There's a little bit of a connection. And the connection is, and this kind of threw me for a loop, because that's the one thing with these software architecture articles, and they're really, it's almost like I'm back in college. You know, the guy threw out the word semantic coupling. I'm like, semantic coupling? What does semantics even mean? It's like one of those words that you throw around, but you don't really understand what it means. And so what I realized, it's named. They're coupled by names. Like if I define if I find a function here called process credit card, then I need to make sure that I have a function over here called process credit card. So that's where there is some coupling, right? And there's also coupling from the front end, because the front end is going to call that right there too. So there's a little bit of coupling, but at least it's communication, really. I mean, you're defining the communication between these different components. And so when you come into this file, it's easy to understand, oh, here's what's going on. Here's how these things communicate. Here's what the assumptions that each one of them make from each other. Because remember, assumptions isn't just data structure. Assumptions could be, what is it returning you? Is it returning you an object? Is it returning you a promise? Think of time. How long is this thing going to take? Is it going to take 200 milliseconds? Is it going to take a minute? What if your previous implementation took 100 milliseconds and now this new implementation takes 5 seconds? Now, what's going to happen, right? Your UI is going to get hung up. So, really useful pattern to use. And you can notice that even like this graph or this diagram can make it seem like it's difficult. The actual coding of it isn't that hard. It's just, that's what I learned about the software architecture in general, is it sounds like it's difficult. They throw all these charts and all these words at you, but they're just, at the end of the day, just words. It's really just these patterns and this way of looking at your system that allows you to create these pretty simple, abstractions that allow you to really encapsulate and put away volatility from the rest of your system. Just makes it easier to work on, faster to work on. So benefits, again, just a recap, stable presentation layer your front end. You got some interface, you got some specific thing that changes, your front end doesn't care. It's not going to change it. Changes can be isolated, so anything volatile can be put away. Expanding or contracting modules is easy. Oh, your form needs a new input? Cool, add a new input. Update your state machine and however that works in whatever framework you're using. Go to your interface. Maybe you got to make a change there, and then go into your specific implementation, and you're done. It's not like this complicated, oh, okay, now I got to go here, now there's data massaging, there's all this stuff inline. It's pretty simple. Easy to understand the connections between components, so how things talk to each other. You don't have to sit and read function after function after function. You don't have to read, okay, now I'm going to this function, and that calls that function, and that comes over here, and that massages it, and then blah, 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 blah. Like, you're not doing this number. Right? I hate that. I hate when you have to jump from one file to another and just like ping-ponging all over your repository, right? You can just go into this interface and be like, and read the contract. And you can document that however you want. I know if someone's software architecture might have something specific, but you could put JS doc comments, you can kind of what I did, whatever makes sense to you, whatever works for you and your organization, whatever project you're working on. Just makes it a lot cleaner. Dry, right? You're keeping your code, you're not repeating yourself over and over and over again. And that point that I had mentioned is when you're looking at this interface, you're thinking, what does my software need? What does my system, actually, let's not use software, say, what does my system need versus how do I implement this specific low-level implementation thing? Oh, it's got these specific endpoints that I got to call. So, okay, I got to create this function, create that function. You're thinking of, this is what my stuff needs, and you build from there. So, Where do you start? How do you implement something like this in your system at the moment? So look for patterns. Where are you repeating the same code? Where are you doing the same thing over and over and over again? Where are you repeating that logic? Where are you doing that data massaging over and over again? Where are you calling that endpoint over and over and over again? Are you leaning on anything heavy? Are you leaning heavily on something that can change? It's outside of your system, like as a third-party library, right? What happens when third-party libraries update? And you got to give it a new data structure. What happens when third-party libraries go away? And you got to swap one thing for another. You got a feature that's in flux. So for example, at Aplos, we might be changing our payment processor. So had we not wrapped all of this stuff in there, we'd have to go through and do all of that logic everywhere. And that inevitably is going to lead to regressions. You know, QA engineers, they're all right. But they usually miss things, right? And developers, we miss things too. I'm just talking crap to Tom, he's not even paying attention. You know, so inevitably there's going to be regressions, and it might cost your business money. And if it's, just think about it in terms of if it's modified, how far will those ripples change throughout your system? That's another big one. And that one can be a little nebulous, because it's always not just about some third-party library service changing. Think about it in terms of, I mean, something volatile will be like customers. Let's say you have some kind of business, and what you do is you provide charting service to your customers. And one of your customers is a software company that just blew up. They got featured on Product Hunt. They made it to the front page of Hacker News. Their user base just skyrocketed. So your charting library is too slow for the amount of traffic that they have coming in now, right? Your charting library is fine. That's a third party that hasn't changed. It's still good. It's pretty solid. It's steady. But this other volatile aspect changed, and now that's going to ripple changes throughout your system. So when you look at volatility, don't just always look at the code. Also consider your client base. Also consider the requests from your project managers, because those guys are always like, oh, whatever, 2 weeks. Oh, you can change this from that. That's fine. So that's also another aspect of volatility. And keep in mind that no design pattern is perfect, right? It's always trade-offs. You can start using these interfaces, but then where do they go? Do you create some kind of third-party library for them? What happens when you get a whole bunch of them in there? Do you keep them in one spot? Do you create one folder? Do you structure them? There's trade-offs. So when you start looking at these things, just keep that in mind. So in terms of resources, on my blog, robaguilera.com, there's a Dev Talk resources blog post where I just put out all of the stuff that I use to figure this talk out. Oh yeah, tacos. Well, whatever. You can go. I know I got to get a better markdown presentation system. But there you'll find like all these articles. So the first one that I recommend starting off with is Design Principles and Patterns. So some of the greats in this field would be Robert Martin. You can also look him up as Uncle Bob. So this dude has been, coding since the 60s. The guy's super old. And so he's got a lot of great, his talk on design and principles, he just goes over all the principles that he wrote about in the early 2000s. And that's where I came across the dependency inversion pattern. And that's where I kind of dived into that one and was able to kind of figure it out a little bit more and how to apply it. So that's a really good place to start. David Parnas, another dude, writing Fortran from the 70s. Just really accessible articles that you can dive into and not that hard to read. And again, it's more conceptual and it's theoretical, but you could see that the application to those theories isn't too difficult. Any questions? So this is a really good talk, and you guys are just bored out of your minds. All right, cool. Well, then I'm actually finishing 10 minutes early, so tacos. Yeah, me too. I'm just like, yeah, okay, whatever. Software architecture, dip pattern, yeah, tacos. Let's go get some tacos. All right, cool. Thanks, guys.